Hello again, welcome back all my favorite coder cats and coder kittens. As usual, this is Becca going by Nightcat or Nightcat's Meow most places online, and welcome back for another week where I will talk with you about Linden scripting language. We are picking up where we left off last week, taking a look at this nice little rollable die that I was working on. My mouse is giving me some trouble. And I said I would go over how it actually read the numbers it came up with. And again, this is not code that I created. This is code I found. Unfortunately, I lost the web tag that had the person listed, but I did mention them in the last video, so I will probably go back, look up their name, and use it in post-production. So it starts out with creating a vector position test, which is equal to rot to up, containing get rotation. So what is rot to up? Let's have a look. Rot to up. This is the main command I didn't know about before I went looking up that other person's code. It computes the orientation of the local z-axis relative to the parent, the root prim of the world. Or, I'm sorry, root prim or the world. All right, so it gets you the relative variation of up is this direction. Where am I relative to that? Pretty cool. And the what it is comparing is get rotation. This gets the actual rotation of the object. All right, that makes sense. We know what the relative rotation between get rot, the current rotation, and what would be straight up vertical is. Then it asks, what if LL fabs position test z-axis if that is greater than 0.5? I actually looked this one up before, and I remember fabs is basically an absolute value. If you don't remember what that is from your old math classes, 1 and -1 have the same absolute value, the same distance from 0. So we'll pull that up here just to get a look at the wiki article on it. This was the other one I didn't know about before I looked at their code. So trying to figure out how to make something cool for you all is actually teaching me commands I didn't know. Returns a float that is the positive version of value. So, positive version. If it is a, and it also mentions, by the way, LLABS instead of FABS. So, float absolute. I'm pretty sure that's what that is shortened for, is absolute. And then LLABS is LL absolute. So, what they say is the positive version of a value. 1 is already the positive version of 1. 1 is also the positive version of -1. So there you go. Absolute value. So if it is greater than 0.5, it then checks is position test z, that is to get the z coordinate. Remember, we've used this on a few things. Anytime you have a vector, you have an x, y, and z value. You can pull the specific portion of that value you want. You can pull out the x, the y, or the z by just using the name for the vector variable, followed by dot, and whichever subpart you want. Is it greater than 0? If so, that gives you one response. If it is not, then that gives you a different response. And in their original code, they actually specified, you know, up, down, bottom, so on and so forth. So in this case, I believe this would have been top, and this would have been bottom. So I changed that by simply positioning the die to whichever face I wanted, seeing what their number came up with, or what their code came up with, and then I filled in that number. Now, if it is not greater than 0.5, it then goes rot to left. So is this angling towards the right or the left? It gets that, and it runs the same equation. Rot to forward, so this is the front and back, and it runs the same comparisons again. So basically what you have is you don't have any one math that will tell you where something is facing that will give you how a cube has landed. Not easily. What you have is you're simply comparing is the absolute value of its rotation on each axis, up, which will give you up and down, left, which will give you left and right, and forward, which will give you front and back. Which of these is facing a relative direction? It's not a thing I personally would have thought of, admittedly. I confess that. I would not have thought of that. But I was able to find that. So your number one takeaway from that should be is if you can't figure out on your own how to achieve something, whatever programming language you're looking at, look it up. There's a good chance somebody figured it out. You can then look at that, you can learn from it. If you duplicate somebody's code, credit them. I made the mistake of forgetting the person's name between this week and last, but I did mention them by name last week. There is credation there. There's plenty of sites out there, Stack Overflow, LSL forums. There's lots of places that will cover this kind of thing. Look up what you need. You may not find exactly what you're trying to create, but you may find something similar enough that you can learn from, figure out how they did it, and then how to use it. For example, I knew about rot to forward before, but I had never come across rot to left or rot to up before. So without having known those commands were out there, I never would have thought of this code myself. But when you go back and look at it, it's relatively straightforward. As far as what I did from there, I simply used a set text, which then you give it what text you want. In this case, this is a 1 with /n. That is a line break. That's like hitting enter. It goes down a line, and then it goes down a line. Set the color using another vector for RGB, red, green, and blue values. In this case, only the green and the blue were actually filled in. And then that just has to do with transparency of the text. You can make it a little bit faded if you wanted to. You can really just play around with that. This is actually the least important variable, I would say, in the entire set text there. And what I did down here is on a collision start, it waits 2 seconds, and then it runs check. Simple enough. Just runs this code. Now, next week, I'm going to create a system where you can actually roll the number of dice you want. So you can say, I want to roll 2 of these dice, and then it will give you both of them and give you totals. You could then use that system to power board games. You can use that to power dicing games. You can use it for a resolution in a Sims combat system if you happen to be so inclined. Where'd you go? But the short version is that is how you make a rollable die that knows what number it came up on. So that'll be it for this week. I've already explained what I'm going to be dealing with next week. Those of you who wondered, I do not have, trying to remember the order of events here. I did see the lawyer's office. Unfortunately, they're not. I think I made a video since then. I am waiting on a response from the original lawyer's office that should have my housemate's papers. If we can finally get a hold of that using the way that the people I talked to more recently said it should get them to turn things over, if we can get that, then a lot of problems start to be solved. If not, then I am going to have to start looking for stronger ways of shaking that tree, because that is right now my strongest option. So, fingers crossed. I think I've got a week left on this sim before I lose it. So, we'll see what happens from there. But thank you all for checking in. As usual, there will be links in the description to the playlists for both this series and Coder Kitty Decoded. Comments, likes, all of those are greatly appreciated. I guess that's it for this week. I'll see you next week. Good day, good luck, happy coding. Meow.